Hello, everyone, and thank you for joining us today. We would like to share with you one core message, that when you bring together Crossplane and Backstage, you can elevate the self-service experience that the platform delivers to both users and operators. The flow is going to be like this: quick overview of Crossplane, integration points, a really cool demo, takeaways, and Q&A. I am Gabriella Brodi, a lead solution architect at TeraSky, a global solution integrator. I started my career many years ago in software development, and I helped a lot of companies adopt cloud-native technologies. I also led for some time the cloud-native New York meetup group. And I'm really thrilled to be here with my esteemed colleague, Scott.
Awesome. Hey, everyone. And my name's Scott. I'm the lead architect in the CTO office at TeraSky, based in our Israel office. Been a Kubernetes contributor for a bunch of years, sysadmin for a bunch as well. And in life, I have three passions: Torah, the Jewish Bible, whiskey with me is not whiskey, and Kubernetes, exactly in that order. That is the passions in life. And let's get started.
OK. So Crossplane. Well, Crossplane brings to the table a framework that will allow you to build a control plane to control via Kubernetes, so API that are Kubernetes API, infrastructure that runs in and outside of Kubernetes. It brings not only the declarative approach, but also the reconciliation capabilities that Kubernetes itself is famous for. And an amazing thing is that as you build your own API and you create these custom resources in Kubernetes, you don't have to build an operator for it. So this is pretty cool, yeah? And also, it recently is now a graduated project in the CNCF ecosystem. Hurrah! What about the experience? Well, if you are using a Kubernetes cluster and you are using your kubectl or building the manifest, let's take a look at this YAML. Like in the first line, we see that AWS is mentioned. OK. And then that we are looking to build a Postgres. We are looking to request a Postgres database with certain size and version. It's pretty easy to define, correct? And what we expect is that once we apply this, we are going to have a Postgres database running in the AWS. Amazing. In reality, this is not only the things that happen. There will be a number of resources that will be created for you: VPC, network, routing, the database itself, and a number of configurations that will make all of this come to real fruition for you. So the experience for the developer is pretty nice, easy to define. But it must be a mess for the operator, right? Well, not necessarily. And this is because Crossplane introduced some really powerful concept. When you need to manage resources that are outside of Kubernetes, you will need something that bridges your API in Kubernetes with the API in the cloud infrastructure. And that is done using providers. Providers are plugins that allow you to do this translation, this connection. Now, you can go ahead and write your own, but you can also leverage Project Outbound, that's under the, thank you, under the Crossplane umbrella, and import existing Terraform provider. The next two concepts that we are looking at are the composite resource definition, XRD for short, and a composition. The XRD defines the schema of your API. So you will have an open API version 3, as of now, way of describing the schema. same as you would do in a REST, for a REST API. Awesome. So this is said, this defines what we can configure and what we want. To do the implementation, the next component that we are going to use is a composition. A composition represents the blueprint of what we are looking to deploy. You can build a pipeline inside the composition, and at each stage, you are going to configure to create a new resource, and in this way define the sequence of the VPC, the routing, all of the things that we saw in the previous slide. Sometimes, though, it's not just about passing a parameter that we get from the API into a configuration file. Sometimes you have to implement some logic. There is some work over there that you want to do. And there are a number of functions that will help you with this task. If you are not satisfied, you can build your own. You can use Go, KCL, Python, and many more languages to do this. So to recap, what the manifest that we saw at the beginning is a composition, is a representation of a composition. The user will apply the composition. The composition will deploy a number of resources, some native to Kubernetes, like deployment, like services, and some that represent the instances that are running outside of Kubernetes. And the visibility can be namespace or cluster scoped, so that the user has also the possibility to do any kind of inspection for debugging purposes, while the operator maintains control to the cluster scope main resources. And let's dig deeper into this. Scott, you ready?
Yep, awesome. So yeah, let's dive right into why integrate Backstage and Crossplane, right? Beyond the fact they're two awesome projects, there's a few key elements here. Number one, Crossplane does not have official GUI, right? A lot of people like clicky-clicky. We're at BackstageCon, portals. It's great, right? We like clicky-clicky. We need that. Crossplane doesn't have one. That makes this a very good candidate for this use case. Beyond that, Backstage lacks out-of-the-box discovery of Kubernetes APIs, CRDs. Let's say there is a great foundation of the Kubernetes plugin that allows us to extend it, but it's a lot of work to do that. And Crossplane and the way that we're working in Kubernetes today, it's not deployments and services and config maps and secrets. There is no one that doesn't have dozens of operators or different CRDs in their cluster, be it things from Cert Manager to Gateway API, which is also outside of Kubernetes, or things like Crossplane and things of that sort. Backstage software templates already utilize basically the same format as we're using in our XRDs. Yes, JSON schema versus OpenAPI schema, but the two are convertible between one another, making this, again, a very good compatibility layer that we can play off of. We also have Backstage, and this may be controversial here, but Backstage is a portal. It is not a full platform. You need to have back-end components within it. There are back-end plugins, but in the end, there are a lot of elements that build up that platform, and Backstage is meant to be that interface above it for us. Crossplane, on the other hand, is an amazing tool for building that API of our platform, and we'll see why that's so powerful through the demo in a moment. Also, both projects have very high adoption, some of the most contributed to projects in the CNCF, and complement one another greatly. So let's talk about the key integration points and then jump into a demo because I don't like slides. Number one, automated software template generation from our XRDs. One of the biggest challenges that we see is when we mirror APIs in software catalogs throughout the years, what we've seen by all of our customers is within about a month, in bad situations, to about 6 months in the really, really good engineering companies, the two fall out of sync from one another, and the front-end form has nothing to do with the actual back-end API anymore. Because I needed to make a quick change here, I made the change, oops, forgot to update it here, made the change here, breaking changes, and now we're in a huge mishmash where we don't know what to do. So number one, how do we synchronize these two together consistently? Number two, automating the ingestion of Crossplane resources into our system. One of the benefits of Crossplane, as mentioned, that SQL database, that is a great thing that could be a component or a resource within Backstage. We don't want to add necessarily a VPC, an internet gateway, route tables, all of the different resources, the managed resources, but those high-level constructs that we build as an XR, I do want to ingest into my software catalog, and I'd rather that be automatic rather than needing to write more YAML. Kubernetes requires me to do that enough already. Crossplane resource visualization. When we're talking about hierarchies of resources, this becomes extremely challenging. And what we want to be able to do is show the tree of resources. I want my developer to have a simple API. But one of the challenges is how do I make sure that when something goes wrong, he still has access to the data to understand how do I go and debug this situation. Finally, we'll talk about day 2 updates and how I actually manage this on a day 2 element through Backstage. And well, you can't do anything these days without talking about AI, so we'll throw some MCP tools and, yay. Awesome. So let's move to some demos here. 1 second. May the Lord be with me. Duplicate. Awesome. So what we have here, very simple environment with basically built off of the Backstack, which is a great project of Backstage, Argo CD, Crossplane, and Kyverno together to build a platform. For those that know, I am a Flux CD lover, but it works the same with both of them. So yeah. Let's jump here into our Backstage environment quickly. And one of the things that we can see here, we have a few different components already added into our software catalog. I could go into, for example, my clustered app, and immediately we can see different Crossplane data. Kyverno, another amazing tool used for policy validation and things like that within Kubernetes in order to give output to our users. And immediately we can start to see the resource tables, right? Of I create an XR, this is going to create a bunch of resources underneath. The different supporting resources of the XRD, the compositions, things of that sort, all giving this visibility both in a graphical and tabular mode. And we can also see, for example, the Kyverno policies. But let's see what this looks like from a creation perspective. If I wanted to come and create a web application from the developer's perspective, I'll just call this demo app01, demo ns01, I don't know. Choose who the owner is. And we can see that we get a form here built off of the OpenAPI schema of my XRD automatically. We can come and fill in here, I don't know, let's say this. Let's choose Nginx as my image because, yeah, why not? I'm going to disable scaling. And we can see that we're able to pull in data as well. For example, which composition, right? One of the benefits of the world of Crossplane is that we have the interface, which is our XRD, and one or more implementations of that interface, making this an extremely powerful using the programming methodology of an interface and multiple implementations of that interface. We can do the same thing at multiple compositions, one doing AWS, another one doing Google, another doing Azure, another doing on-prem implementations of the same API for our developer, for example. So we can select what we want here for the composition I want to use. We can do next, select which cluster I want this to push to. And this is where I have a major issue with a lot of different clicky UI things these days. A lot of people say, ooh, writing YAML, too difficult. Let's go and throw everything that we've learned as an industry over 20 years out the toilet and just have the thing do kubectl apply. No. GitOps is the correct approach. We can have clicky UI above the correct processes in the backend, so we can give a better consumption layer, but that doesn't mean we throw out everything that we have learned as an industry that has gotten us better MTTRs, better configuration, easier drift detection, and overall a more production-ready environment. So what happens here? This got created. We get a pull request. Because Argo CD does take some time to merge things, I'm just going to confirm the merge, and then we'll go and look at what it did, because, production. We can go to our files changed, and we can see that this actually generates for me the XRD automatically for me in the GitOps repo for my environment. If I come straight into the environment here, I can do now kubectl get application, and Argo CD takes a minute. It'll take a minute, but this is going to run. In the meantime, we can show another part, and then this will show up. Thank you, Argo CD, for taking a long time to sync things. Another thing that really matters to us, though, is what do I do day 2? I have a new composition. I have a new API that I want to install. So what I'm going to do, I've already just created these manifests. I'm just going to quickly, hold on. Where in the world is this? OK. There, kubectl, apply -f, crossplane, 4 XRDs, DB as a service. So let's apply that. And then let's also apply the composition. So basically, all I've done is created a new API for my database and created an implementation using Go templating in this case, just because, yeah, it's easy and I was lazy. So we have that. If I come to the Create tab, immediately we can see I now have database available for me. Why? Because I set it up for 10-second intervals because, demos. But when I come here, automatically what I can do is start filling out the name, db test 01, let's say, choose demo ns01, choose the owner that I want to have this, choose the size that I want, let's say 1 gig, and I want to use version 17.1 of Postgres. Do a next here, next, select which cluster I want this to deploy to, review, and create. And this is going to automatically go and do the same thing, create the PR for me for my database. And this becomes a really simple approach for developers to start to consume these different services that we've exposed to them. The benefit being, because it's all GitOps, if they want to take this manifest and Git push it up directly, just commit it and add it to Git, they can. They don't need to go through Backstage. Backstage is simply that other interface if they want to, which we do recommend because it saves a lot of issues, but to each their own. If I came here now and just looked at the applications, we can see that this automatically synced down. We're using application sets from Argo CD in this case in order to auto-generate the applications for these manifests. And we can see that this gets created. If I go now to the Backstage UI, and I go to my home page, we can see that we have demo app01 that was automatically created. We can see that it's already synced. And we get a bunch of failures of policies. I'm not allowed to use the Nginx image. There's some issue with the auto-scaling being disabled. And the web app FQDN must be unique, and it isn't because I have another web app with that same FQDN. So how would I go about fixing these? And this is where we bring the scaffolder into the context of the component itself. And actually, what we're doing is we're ingesting the XRDs as APIs also into the catalog. As part of doing this, what we're able to do, I just need to log into GitHub here. And what this is going to do is it's pulling the file that's in Git that backs this component. At the same time, it's going and looking at the API, generating an on-demand field extension schema for us in the form, overlaying on top of that the values from what's stored in Git, and allowing us to basically do a PR flow to update our manifests. So we can come in here. I could change anything that I wanted to. I'm just going to change this because it's a really production policy. Doing Nginx latest makes it not fail. So I can just do that. I can set scaling to enabled. I can do a review and create. And this is going to actually come create that new policy for us. All fixed, and everything is great and working as we expect it to. Now, let's talk about the elephant in the room for a second, which is you can't do anything today without AI. And one of the great things in Backstage is the new MCP integration with the dynamic clients, dynamic client registration, which is great in the new front-end system. So let's take a look at how that works here. All of these plugins have different MCP tools exposed from them. And let's look at what this experience is going to look like. I'm just going to quickly start the MCP server. And this is going to log me into Backstage. Great, we're logged in. I can come back to here, and we can see we have 8 tools in this environment. We have some from Kyverno, some from the catalog, and some from the Crossplane plugins. Let's use GitHub Copilot here with Claude. And I don't know, let's just say something like, what Crossplane resources are connected with my component, my web app, and what policy violations are there? And if we run this now, Hopefully Haiku won't be too slow today. And we can see that this is going to immediately come and run the different MCP tools in our case. It's going to get the catalog entity. It's going to get the Crossplane resources. It's going to get the different entities here, and hopefully at some point it decided that it works, yay. And basically we can see here all of the different data that we're looking for on our components. Right now, this is, again, the general idea being we can now expose. We've built MCP plugins, for example, that use the scaffolder that allow us to automatically come and ask the users for the data that they need in order to then go and fill out the scaffolder and actually do a scaffolder execution from their terminal directly from their IDE and work from there. And I think the whole idea, and this is the real power of using Backstage together with Crossplane, is that we have that separation of the back end and front end. And what in the end that's going to allow us to do is really create a powerful combination where we can have multiple interfaces above that single really powerful interface. So let's talk about just some key takeaways here for a moment, right? Crossplane makes infrastructure programmable, right? It makes it very easy to declare what I want to do, especially in Crossplane v2. And Backstage makes it consumable, though. Crossplane still is not consumable. It's still Kubernetes. And as Kelsey always says, Kubernetes is a great platform for building platforms, and it is not the platform that is our developer experience itself. As a friend used to always say, giving a developer access to Kubernetes is like letting me fly a 747. Not the smartest idea on planet Earth. It's a perfectly dry solution. We're not repeating ourselves. We're getting automated software templates based off of things. We aren't creating catalog info YAMLs. We're actually adding annotations on Kubernetes resources that through a catalog provider are actually being ingested in as the annotations on our resources within Backstage. Again, I anyways need YAML. Why do I need another YAML file when we're talking about the Kubernetes ecosystem? This allows us to consume these templates and use the GitOps pipelines, right? It gives us that clicky UI. It gives us the good consumption layer without breaking industry standards of our GitOps pipelines, and it allows us to enforce policies using things like Kyverno in our ecosystem. The developers get their autonomy that they want, but our platform engineers, they get to keep the control. And that's the real balance here that we're trying to play. So really, I think the key message, though, is that self-service portals, together with the self-service platforms, right, which is really that back-end platform API of something like Crossplane. It can also be, you can pick your poison, and the same thing works with, other projects like Crow, or you could build things with other projects in the ecosystem. Crossplane is my poison that I like because it's just the best in the industry, but everyone can choose their own. This can also be done with Terraform if you really decide that that's what you want to do. And yeah, so with that, thank you. And if there's any questions, we'd love to take any questions.
Over there.
Exactly. So there's multiple approaches for how we can do this. I think working at an SI, one of the great answers is that I can say it depends because we have customers doing things in all different ways. I think that really the way that we've done it mostly is through Kyverno policies that give back the feedback to the developer saying, hey, version 17.1, have a rule that says version 17.1 is deprecated, and you should upgrade to 17.4 till this stage. On the overview of his component, he sees that failure of the Kyverno policy, can go to the scaffolder component and update it that way. Obviously, it all comes down to that question of the developer autonomy versus not. I like the approach that public clouds have taken with Kubernetes. which is they will force upgrade you if you fall out of the support window, but they will let you know enough time in advance so that you have more than ample time to actually do that upgrade on your own. If you hit the day of end of support, sorry, I'm upgrading you, and that's your problem. But yeah.
Any more questions?
Awesome. Thank you.
Done.